Welcome to my channel, and here we are going to work on these problems, and it has to do with the construction of the orthographic views of this object, and we are starting with this one first. And based on the symbol that we are given here, we have to produce the orthographic views of this object in first angle projection, as we are asked to draw the front view, the end elevation or side view, and the top view of these two objects. But we are starting with this, as I said. Now let's look at the dimensions that we have on this object. This is the direction of the front elevation. Let's take note of that. So, and under here, so we have this shape here. So there is a feature here, and that's going to give us a rectangle when we are viewing this object in this direction. Then after that, we have this shape. So we have this shape that we see here, and then this hole will be hidden from us. The hole here will be hidden from us, and then we have this curve, so it will be hidden from us in the front elevation. So the distance from here to here is 120, and distance from here to here is 20 millimeters. From here to this end is 50. Then this line is inclined at an angle 45 degrees to the horizontal, and then we have that the center line of this hole from this end is 25, and diameter of this circle of this hole is 16 millimeters. Okay, and then we also have that the total distance from here to here is 60 millimeters, and from here to here is 12. From here to here is 12. Okay, so those are things that we are going to put together for us to produce the front elevation of this object, as we are going to have a video for each of the parts that we are going to draw it orthographic view. So let's start with the front elevation. Okay, so the first thing that we have to do for the front elevation is to draw a horizontal line. So here we draw horizontal line like this, and then so we take our set square, so we draw a vertical line here like this, and we are going to take a measurement of 120 millimeters, which is the total length. So 120, so this is 120 from this end here. So at this point we are going to draw a vertical line. So here we have a vertical line. Then the next thing that we are going to do is that, so the rectangle that we have at this point has a length of 120, but distance from here to here is 5 millimeters. So on the horizontal, let's take the measurement on the horizontal first before we go for that of the vertical, as we have that distance from here to here to this point here is 50 millimeters. So we take a measurement of 50 millimeters from this end, 50 from this end. So this is 50. Okay, then I will also take 50 from this end. Then we now have 20 millimeters in the middle. So we have this. So those are the measurements that we have on the horizontal. And then so I'm going to draw a vertical line here. So here we draw a vertical line down, and here we also draw a vertical line down. Alright, so then the next that I'm going to do is to take so we take 5 millimeters. So 5 millimeters up. So 5 millimeters from here to here is 5 millimeters. So we take 5 millimeters. So this is 5 millimeters here, and we are going to draw horizontal line. So we draw horizontal line all through because of the end elevation. And then the next that we have here is that so the distance from here to here is 15. So we take 15 millimeters again. So from where we have that 5, where it ended, we take 15 millimeters up, and we draw horizontal line all through. Okay, so we have that. The next that we have here is that so we need to get this shape from here. this shape here. So this line, we have to draw it on this line. So we are going to make use of our 45 degree set square. So we set the 45 degree set square. I'm looking at where it started from. Okay, we have it here. So it goes like this. And then, so the distance from here to here is 12 millimeters, as we have from here to here is 12 millimeters. But we have to get this point first. So total height of this, okay, total height of this is 41. So I need to take a measurement of 41 millimeters from here. 41 millimeters, this is 41 millimeters. So I'm going to draw a horizontal line. So for that, so we draw a horizontal line. Alright, so we have that there. But what we want to do now is this line, because this is a non-isometric line, and again, so what I observe here, we are not given the distance from this point to this point. Okay, then from here down is 12 millimeters. Okay, that's settled. So just take 12 millimeters. So 12 millimeters. So this is 12 millimeters. So we locate this point. So we are going to draw a horizontal line all through. So we have that. So then I can now take my set square, 45 degree set square. So setting it at this point. Okay. Alright, so so we take the 45 degree set square, so placing it at this point, and we draw this line. So I'll just make it a thick line at once. Okay, so we have this line. Now I bring it to this point, so we draw from here to here. Alright, so let's bring out the outlines that we have produced, so to make it more feasible. Okay, so this line also will be a thick line, and then this line, so from here to here will be a thick line, and from here to here it will be a thick line. Then coming up here, so we have this line to be a thick line. Okay, then so this line, so from here to this point will be a thick line, and this will also be a thick line. Okay, then coming to this end, so we have this line from here down is a thick line, and then coming here from here down is also a thick line. Now, so the next thing that we are going to put here, we have this hole hidden. So the hole, it will be hidden in front elevation. So this hole and this hole will be hidden in the front elevation, and we are told that the center line of this hole from this end is 25. So the same applies to this. So we have to take a measurement of 25. So 25, so to this point. Okay, so we do the same thing here. So 25, so this is 25, and we are going to draw a vertical center line, here. So we draw a vertical center line here. Okay, so at this end also, we also draw a vertical center line. Alright, so the diameter of the hole is 16. That means we have to take 8 millimeters to the left side, 8 millimeters to the right side to make it 16. So we do the same thing here. So 8 millimeters to the left side and 8 millimeters to the right side to make it 16. The next thing that we are going to do here is to draw with short dashes line to show that the hole is hidden from us in the front elevation. It's hidden in the front elevation. So we also do the same thing here. Alright, so we are told that it's a true hole. That means it goes to the other side. So that's why I drew it down. So this is how it should be. Okay, so we also draw for this. Alright, so we have this. Then another thing that we have here is this semicircle that we have here. So it is hidden in the front elevation, and the radius is 20. So we need to we come up here. So we take 20 millimeters. So just take 20 millimeters here. Okay, this is already 20 millimeters. So it's already 20 millimeters. So what we just need to do is that so the thickness is 20. So it is 20 from here to here. It has the same width as this, which is 20. So that 20 is already taken from here to here. So what we need to do here is to make this line. So just make this line short dashes line. That is from here. So make a short dashes line like this. So, and then so we have this on this part too. So we also need to make this the remaining here. So make a short dashes line. Okay. Alright, so here we have the front view. This is the front view of the object. Let's meet on the video for the plan. Thank you and God bless you.